That's why this is happening.
There's a lot of thumbs up on this comment.
Yeah, let me jump into it. We'll talk about temperature mapping, but this can be applied to any area where IoT data is brought in. We're just using temperature mapping as an example. When I say temperature mapping, it could be RH, pressure, any sensor time series data you have from the line, from the facility, you could do that. But today we're going to use CTM or continuous temperature mapping as an example. We'll talk about the status quo, what's the problem, and how are we solving it? How is it better? Architecture, demo. So I won't take too much of my time, thanks to the crash. If anybody has done temperature mapping, it is not fun. Over the last 20 years, Valuation XLM has done quite a few studies, maybe over 100 studies all over the US, Japan, Europe. We have done it. We have a lot of experience in this because we have done large facilities like 1.5 million square feet, distribution centers to cold boxes, refrigerators, you name it, we have done it. So we had established a process here at Valuation and XLM. Like typically what happens is, you figure out where you want to place the data loggers, then you pick NIST calibration certified data loggers, you program them, you ship it to the facility, or you take it there, you locate everywhere. And let's say it's a 8-day or a 14-day study, you place it, then you collect all the loggers, you upload the data, you get the BMS data, then you put everything into an Excel, it's like a salad, you throw everything in, you scratch your head, jump around, then you work for a day or two, get some results, then prepare a report. It's messy, it's error prone, it's not fun, and it takes time. So that's a main thing here. So what is the solution? So let's assume that you can put data loggers that are RF compatible. You can even use your guest internet to send all the data in real time to the cloud. Then in a secure way, we can. Normally it's a VPN tunnel that's established. Then you can send the data out in real time. Our system can ingest the data from the loggers and give you analysis as the temperature study is going on. And the end of the study, it can compare it to your BMS sensor data, which you can upload. If there's a way to get it in real time, we can even do that through APIs. But normally, system, it's a nightmare to talk to them and bring the data in real time. So the idea is that, Tanay, you can see my screen?
Yes, sir.
Okay. Yeah. We are on slide number 4. It seems there is again issue that we are facing. Sorry, and thank you for your patience. We'll fix this soon.
Guys, I don't know, something is happening on my end. I have no idea why this is happening. Can you see my screen again? Sorry.
It's loading. Navij, if you want to switch off your camera just in case, because it's getting crashed,
Yep.
right? So
Yep. So I'm going to move to the architecture. Tanay, go ahead and walk them through the architecture.
Thank you so much, Nagesh. The architecture page hasn't loaded yet.
I don't know why it's not loading. Yeah, it's loaded.
Yeah. As for the architecture, our entire authentication flow is managed by Azure AD. It also manages the permission and groups of different users. We have 2 different flows for data ingestion. One, you can bring in your own data. It could be the data would consist of your fixed sensors, the temporary sensors, the loggers that are surrounding the fixed sensor, and a grouping data informing the mapping between your fixed and temporary sensor. We also have real-time ingestion pipeline for collecting the data from wireless cloud-enabled RF sensors over using our AWS cloud, which triggers a flow and can ingest data from as low as 5 seconds per ingestion to any time interval of your choosing. We pre-process it, we compute it, we cleanse this data, and then we store it into a relational database. And on the fly, we have also connected it with a really nice visualization platform, that is Power BI. So Power BI is able to interact with the databases and provide you with a real-time feed of this data set. And alongside, you are able to, within a few clicks, generate a Power BI dashboard. And I'll be soon giving you a demonstration of the same. And until Nagesh sir joins, I'll also tell you about another key feature, then that is chat with data. So we have used the power of AI so that you can interact with your data in such a way that not only you can get some summary statistics, but you can also request for different statistical analysis, test, and even visualizations to be generated on the fly just by giving simple prompts.
Tanay, I think you should jump into share your screen and show the demo. Sorry about that. This app is crashed 3 times now. So my apologies.
So I'm really excited to show you guys the application stack. So here I have logged in as from my Azure AD account for my Microsoft 365. And over here, our very first tab is the dashboards tab, which will show you each and every dashboard that you have created or you have access to. We have a job tracker, which will enable you to track all the requests of different dashboards that you have requested for creation. Right before this demonstration, I created 2 different dashboards. One using my own Excel file. We have a sample data set over here, which I'll be just showcasing in a moment. And we also have 2 different wireless sensors located on site, which are feeding data real time. So I have a sensor regarding those, a dashboard entirely made on those as well. We have a feature of requesting dashboard. So within your organization, you can ask and get access to different dashboards created for different studies within your domain. We have the create dashboard flow, which within a few simple inputs, you can go about with creating the entire dashboard, a Power BI visualization. So how it goes about with this, it will ask you some general information. So let's give it test dashboard. I'll give it a general description of testing. And we have a study that started on the 17th of July, 2024 at 7 a.m. This is a sample data set that we are using over here, followed by the study ending it in a week period. And over here, I have opened up the data set. So we have 4 different fixed sensors that are being put on the manufacturing line. These sensors can collect the data in different formats. It could be temperature, humidity, even locations like latitude and longitude. We are able to ingest these data along with a repetitive timestamp. So you can see there is a 5-minute interval between each and every data. Surrounding them, we have 19 different temporary loggers. These are RF sensors, which are monitoring these sensors. And we are going to look into the deviation of acceptance, a 5% deviation in the temperature, so that it's an acceptance of this validation. So let's go about with uploading this data. So I will provide the fixed sensor, followed by grouping data. So we have an Excel sheet of the entire grouping data mapping, telling which fixed sensor maps to which temporary sensor. And then we can also upload the temporary data. And with this, the data set can be ranged in millions, but it is able to completely process it without affecting your current work. And with this, I can submit a request, and this goes into a cloud backend and goes about with processing. You can also track this request going about in the job tracker section. So you can see that, okay, I have given a test of, I've created this dashboard and it's still being processed in the backend. So to save the time, I'll go about with demonstrating the different dashboards that we have created. So this is what this dashboard is going to look like. This is our development environment over here.
Tanay, just zoom in a little bit. They may not be able to see it.
Is this good, sir?
Yeah.
Yep. So first tab that we have is fixed sensors over here. So we have the information of a fixed sensor. So this is the uploaded, this is our cloud data over here that is being shown. So we are able to see the census feed, the timeline graph of it. We can also see the basic summary statistics, that is minimum, maximum, and the average temperature recorded by the sensor. And similarly, we are also able to see the same thing with the loggers that we have that we have placed surrounding the fixed sensor. So we have the different summary statistics, the feed of the logger, the timeline graph of it, and we also have a t-test to signify whether there is some other factor influencing the census data or not. So with the low significance, we are certain that, okay, this sensor is independent and its feed is not influenced by the fixed sensor. And then we have the temperature mapping page where we are able to evaluate the deviation between them and also see that visually. And we can also conclude whether the test case has passed or failed. So this is one of the graphs, and I have another one, which is a slightly bit more data over here. So let's go about with this one. So this is the one with our study period that is starting from the 17th of July for a week period. So we have all of the different 4 fixed logger sensor data over here. We have 19 different temporary loggers. They are feed each and every summary statistics of them and also significance test on these sensors. So we know that, okay, from the very testing point of view, these sensors are not been influenced by the fixed sensor. And then we can go about with logging into the variations surrounding the fixed sensors. So we can see over here, we have one test case that has passed, and that is because the deviation is within the 5% range of the surrounding temperature. And we have 3 situations where it has failed because the deviation exceeded the 5% benchmark. And now I would like to bring about one more exciting part, that is to chat with data. So chat with data on its own pulls the data files of the uploaded for that dashboard. So we have the fixed data sent over here. So let's go about giving it some prompts. So let's start with the very basics one. So if I were to ask it that what is the average temperature of this data frame? So let's see how it processes it. Okay, so it gave us the average temperature. Now let's go level up. Let's see if it can create any graphs for us. So what I'll do.
If you can please zoom in a little bit, your font is a little bit small. I think your screen is wider. If you can please zoom in a little bit.
Is this good?
Yep, thank you.
Let me refresh this. Okay. So let's go with statistical analysis over here. See.
So these are prompts, natural language prompts, right, Tanay?
Yeah. So right now we are going a bit more. We are going to see if it can perform statistical analysis on our data set. So I simply asked it that, can you perform Fisher's one-way test for the ID?
Yeah.
That XTG139, and it was able to provide us with the statistical analysis. So what chat with data does is that it uses Python and creates the code to perform these analysis on the fly. So you are able to avoid the mathematical errors that your generative models are traditionally prone to.
Yeah.
Because over here, the generative model focuses more on structuring the proper algorithm in Python so that you can automate that.
So it's generating the code, and the code will run like the code will run anywhere, right?
Exactly.
Yeah.
And we can also go in about asking some abstract questions over here. So I can ask it that tell me about the census ID, which have the most variation. Then it is able to identify that as well, that okay, there is a temperature, the sensor TXCP002 has the most variation. And let's see if I can create something more. Yeah, there you go. So I asked it whether it can create a timeline graph for me where it marks out the highest and the lowest temperature in that graph. So you can see that it gives a visualization of the entire timeline view. I've zoomed in way too much, that's why it's getting stretched out like this, but it is able to identify the lowest point as 20.83 and also the highest point, that is 23.37 of the graph. So this is what we have implemented. And with each dashboard, you can interact with the data set as well on the fly.
The question is, Tanay, is this using R for these queries or for the test sample? It's not using R, right? We're using just Python code directly,
We're
correct?
using Python. So we are using Python, and it's the code is able to even import different statistical libraries required for it.
Yeah.
And it's apt enough to run the code on its own. So I can also show you the review of the code. So you
Yeah.
can, it has generated the entire code. So I can even reuse it down the line for my analysis.
Got it. Got it. So now, can we just again, what you showed is a one use case, right? Like temperature mapping. But technically, you can import any time series data into this particular framework and do the analysis and do everything that you showed. It doesn't matter to you, correct?
That's correct. It is able to, as long as you can get the data feed in numbers, it can process it. It's as simple as that.
Yeah. And what about applying the machine learning models? Can we automatically apply the models, or do we need to some manual intervention from data scientists?
So the machine learning models are able to identify different trends among the data. So even if it's a complete random data set that you're providing to us, it is able to understand how exactly we can fashion a forecasting to it. We are able to monitor it accordingly, and the data cleansing and processing that happens ensures that there is no corruption in the data that is being fed to the ML model. So
Yeah.
it goes down, as long as it's a decimal number, we can process it.
But this processing, right? Can the LLMs automatically determine which model to use, like how your Python code is generated, right? For what you showed me in chat with data, can your LLMs automatically figure out based on the data set and your prompt, figure out what ML models to, what is the best ML model to use for that situation?
Yes. So we can have our data fed to an AI agent that will evaluate and test different parameters
That's what I
to
wanted to. Yeah.
check which ML model, which forecasting or analysis model fits the best. And it can real time switch between different models based on the nature of the data. So you get a flexibility on that end.
And if we have a lot of training data, right? Let's say we have 1 year's worth of training data. So we can use the first 10 months to train the model, right? Because we already have the data. And of course, we have real-time data, we have future data, right? And but we can also use the data that we did not use for training, let's say the 11th month and the 12th month, to put as input into the model and see what it predicts, to see, if the actuals match with whatever it's predicting, correct? That's one way of testing it, right? The hypothesis testing we can do, correct?
Yes, we can look into the marginal error, and we can
Yeah.
also evaluate the efficiency of the ML model as well.
Yep. And is there any limitations of scaling up? Because manufacturing lines can generate lots of data, right? In sometimes billions of records, because they're collecting many parameters in a very short period of time. So it can really add up. Is there any limitation in terms of applying this entire framework or can it scale up?
It can easily and efficiently scale up from, even if you were to put in thousands of, let's say, IoT sensors and process all of them in parallel. We don't see any situation where the architecture will crash or will overflow.
Yeah, the reason is we're using microservices at the back end, correct?
Yes, we have it all in decoupled and microservices, which is able to process everything for any unpredictable load as well.
Yeah. Can you go back and show if that that dashboard got created? Remember the one you just tested?
Right. So we have this dashboard created over
Can you
here.
just focus in, please?
Yes, let me just zoom in real quick.
Yeah. So that got completed, right? The one you just created in the demo, during the demo.
Yes. So I can also view this dashboard.
Yeah.
There we go. So let me go in full screen.
Yep.
So we have it. So the study period is correct. We have 4 distinctive sensors over here with us.
Yep.
The entire timeline of them. Similarly,
Yep.
loggers, 19 of these sensors, and the final part of temperature mapping where we get the study of these data.
No problem. Tanay, thank you so much. We are out of time. I really appreciate it. And this was a good demo.
We have one more question from the
Yeah,
participants.
you can also put up the poll, Kashyap, please.
Yeah. So the question is for chat with data, is it using R for the queries? For example, for chi-square test.
No, we answered that.
We answered that, Kashyap. We are using Python on the fly to generate that one.
Okay. So we have put the polls.
Yep. Let's give them 2 minutes, for the polls to kick in and get some responses back. And we can close the session, Kashyap.
Yeah.
Tanay, when you're waiting for the polls, right? So all this comparison between fixed sensors and loggers, because there's some logic behind it, because we need to make sure that the fixed sensors are in the right location. That's why we do temperature mapping. We have to prove that, let's say it's in location, our formula is that laterally it should be a logical space of 40 feet lateral, let's say 5 feet vertical either way. So it's 10 feet vertical. That's like a space, right? We define like a cuboid or a cube space, imaginary space. So we want to show that this temperature location represents the temperature of the entire cube, imaginary cube, within plus or minus 2 degrees or whatever the spec is, right? So that's why we do the comparison. And our system can automatically figure out, right, based on certain parameters we specify, like the knowledge base, it can automatically match. We don't have to manually match it, correct? Saying that A will go with B or C will go with D, we don't have to do that, correct?
Yes, and we also have the latitude and longitude value of those sensors as well.
Correct.
And calculate the proper Euclidean distance
Yeah.
to make sure that it is in the compliance range as well. So if we have a 20-meter range, we can assure that all of them are in that sphere of 20 meter surrounding that fixed sensor.
Got it. Yeah. So there's a lot of automation here and more accuracy.
Yes.
Okay. Kashyap, are we good?
Yeah, we are good.
Yep. Thank you. Take care.